Okay, so I plan this, yeah, and then hi everyone again. Welcome to the LPS lecture. We actually we went through several concepts on Python last time around. The important ones are, first of all, we kind of talked about the tuples, the list as data structure, and then how we can operate on them. That was the main focus from last time. I think you guys remember that. Today we will be continuing with that. Actually, the on Python programming essentially. So Python programming itself, we covered a lot of things so far. So as you know, we talked about the control flow, the data flow itself, with starting with various data structures, the string, the integer types, the floating point types, things like that. Then in the last lecture, we covered the two other new types like the tuples and the lists, and we went through how to operate on them, how do we index them, things like that. So I think right now we have a good understanding of how the Python programming actually works, so that we can take the next step of going through some of the advanced concepts. Yeah, we also talked about the collections and basically like what collections mean, which is another data structure that we talked about when we discussed tickle essentially, and collections as a data structure, what Synopsys supports, that we talked about. So similar collections are available in Python. We talked about them. So today what we are going to go through is basically some of the advanced functions. Essentially we are going to talk about how to pass lists and keyword dictionaries to functions. Then we also will talk about something called the lambda function, which is actually it's a function generator. So we will talk about that. Then we will talk about some of the functions like apply, map, filter, reduce, and we also will go through some more understanding of the list, like list comprehensions. So let's begin today's lecture. So how do we pass lists as arguments? So the list can be passed in cases where there may be a variable number of arguments. So this is something that we saw in a tickle as well, or like when we specify this special parameter as a function, and then you can pass the arguments. So here there's a list arg.py. Here we are defining this function as sum. The function's name is sum, and then we say basically the arguments are we denote it like this basically, and then we say like the result is 0 for arg in args, result plus arg, and then the return results. So here, since the star args is itself is a pointer, we can actually then pass a list into this. So now, like if you say like print sum of 1, 2, 3, the answer is 6. So note the syntax of how do we pass the arguments. So then now the keyword arguments essentially, like so the caller of a function can place the arguments in the correct order. So that is the positional argument. So that is this is something that we saw even in tickle as the positional versus the non-positional stuff. Sometimes we can actually change the order by assigning keywords. So how do we pass that? So for example, so here, like in this example, it's a function with arguments in the wrong order, but the arguments are passed with the keyword syntax so that it doesn't matter. So how do we do that? So in tickle we saw some newer constructs to handle this kind of an issue. We talked about that. Now here let's see basically like so print hello basically like, and then we have the first name equals and then the last name equals, and then we can say like okay pass the hello print the first name last name, and then those are the two names that are passed into the function. Now if you want to so standard one is basically like I mean you can just write it like I mean what is the if you just say hello Sam or David Shrill Cheryl, then it will print exactly the same. But if you want to actually interchange the argument, we can just say that last name equal to Cheryl and first name equal to David as a hard assignment with these function names, then it will actually print appropriately. So even though here the order is interchanged, basically the last name comes first, this is first, and then this is second, but it prints correctly, which is the first name and this is the last name. So this is one way to pass the keyword arguments essentially. So when we have like specific like when we change the order, then this may be useful. So what happens if you are missing keywords and the positional arguments? So this is also like something that we saw like how do we pass when we talked about tickle. What if some arguments are missing and we want to pass it appropriately? There we make use of the tickle's understanding of what strict substitution strings, basically the curly braces and the quotes, and then we made use of it to pass these kind of arguments. So here how do we do it like in Python? So we saw already like the star operator which is used as a variable length of argument. So we can use the same concept to designate all arguments after this as the keyword arguments. So and this is something that is new in Python 3. So here we have an example. Again the area we say basically like x y, and then we say like the star operator, and then we say units equal to inches. So now when we do print x times y, and then we say like square, and then we say basically like square this particular units. So if you say basically like 2, 3, and then centimeters, it gives you this square centimeters. So the star essentially like I mean it captures this. So if you omit this, then the units is taken as inches. If you put it, then the units become whatever that star that you specify. And now the other important thing is passing the dictionaries to functions. As you know, like dictionaries are the associative arrays that we saw in Perl, and then we also saw similar concept in Tickle, and in Python they are called dictionaries. I hope you remember that. And we are going to be talking about dictionaries even in more detail later on. But here in this one essentially like we have this particular function called print, and then we specify it. Now we specify 2 stars and then the KW args. So this is the keyword argument. So basically like for each key in keyword args dot keys essentially, and then we can print what is the key and what is the value. So here we say basically like okay, so here is an example as like user info is dictionary name, user ID, and home directory. There are 3 fields here. So if you do say like print dict star star user info, I think like this one is print underscore dict actually. So and then the output is essentially like, I mean, user ID is 593, name is David, and then the home directory is particular home directory like /home/user/David. So one thing that you want to note is we talked about this earlier also, like when we talked about the dictionary database or dictionary data structure. The dictionary entries are unordered, unlike lists or even tuple for that matter. So that's the reason why we, even though we specify like this, basically like the user ID came second and name was the first. When it printed out, basically user ID can be first and then name is second. So since it is unordered, this is what you may expect. And the other specific thing is basically when we pass the dictionary as an argument, we need to specify with the double star. Now, how do we pass the dictionary arguments essentially to functions? So the dictionaries can be passed as arguments even to normal functions wanting the positional arguments. So how do we do that? Essentially, like, so here again define the area as xy units inches, and then here now we have this data in a dictionary. So how do we pass that information? So here we say basically like area info is this is the dictionary that we create, which is x equal to 2, y equal to 3, and then units equal to centimeters. So the 3 different keys, basically x, y, and units, and then their values are 2, 3, and centimeters. Now we can actually, even though like this is a normal function, we can pass this dictionary into this normal function by just specifying the double star area info, the dictionary name, and then the output is just 6 square centimeters, which is essentially the same 2 times 3, and then puts the centimeters square centimeters as a unit. Okay. So now we come to the another major topic that we want to talk about today, called the lambda functions. So the lambda functions are essentially, they are shorthand versions of def statement or a defined statement for a function. It's useful for inlining functions. That means that basically you can define functions on the go, and also in other situations where it is convenient to keep the code of the function close to where it is needed, so where it is getting used. One thing to note is it can contain an expression in the function, can only contain an expression in the function definition, but not blocks of statement. There's only one expression essentially. So we cannot specify like if statements or for loops, etc. inside the lambda function. And then a lambda returns a function. The programmer can decide whether or not to assign the function a name. So this is another peculiarity. Even though the lambda returns a function, the programmer can decide whether to assign it to a function to a name. So let's see how we can use this lambda function. So here is one example. This is a very simple example. So in normal course we define a function called sum xy, and then we say return x plus y, and then if you use it we can say like sum 1, 1, 2, and then this will result in 3 as it shows here. So if you want to use the lambda function, we can directly create like sum 2 equal to lambda xy, and then we need to specify this column same as here, just x plus y. So this is like just a shorthand representation of this line to here, and then when we say like sum 2, 1, 2, that's also the same. So we can use these lambda functions wherever the function objects are required. They're syntactically, as I mentioned, like restricted to a single expression. Semantically, they are just syntactic sugar for the normal function definition. Another thing is basically the lambda functions can reference variables from the containing scope. So again, like we can limit to that. So another thing is basically we can say def make incrementer and with n, and then this function we can define it as return lambda x plus. So if you define a function like this, then if you say like you can say f equal to make incrementer 42, and then f0 will become 42 and f1 is 43, etc. So you can call it this kind of a lambda function. So you can use this lambda not just as a function, but I mean in between functions for quick rather than like I mean actually using a function inside a function, you can use like a lambda inside a function and get better coding that way. So another example is like you can pass this a small function as an argument. So how do we do that? So let's see, like I mean, so we define a dictionary, actually a list, or yeah, dictionary basically, which is called pairs, and then we say like okay, the pairs is 1 1 2 2. Say we have this pair, and then we say like we sort the pairs dot sort, and we define key equals, and here we can specify a lambda function, lambda pair. The pair is actually pair 1. Now if you execute like pairs, you can actually now sort the this thing. In this case actually it will give you like basically like 1 1 and 2 2, but you can actually sort it with actually like reverse sort on this one. So basically like you can actually the pair will now become, if you execute the pairs, it's essentially it's 2 2 and 1 1. So this is one application essentially like where you can specify the lambda expression to return a function essentially. Okay. So now we go into some more details essentially and other functions essentially. So here we talk about apply. So In very general context, you may not know ahead of time how many arguments need to get passed to a function. This is like a typical scenario essentially, like the variable arguments, and also like if the function itself is built dynamically, then you won't know essentially. So the apply function calls a given function with a list of arguments packed in a tuple. So that's the usefulness of apply. So here we can say basically like our function definition is sum xy return xy. Now we can actually call this to execute this function using apply, so that it's basically we pass this this entire function as a tuple, basically that is sum 3 4 and then the result is 7. The apply can handle functions defined with f or with lambda, so those things are possible as well. Okay. So now also like apply can make the third argument, which is a dictionary of keyword arguments essentially. So here an example, name arguments, star arguments, we know that this list and then dictionary. We want to print this whole thing, and again here we have defined these two variables, and if you want to print this, essentially we can just say apply name arguments args and AW args, and then it prints the whole thing. So again you can see that basically you can pass the function name, its arguments all in one shot, and then you can get it executed. So here if it is a variable name, like a variable length of the arguments, you can still get executed with this function. So essentially like the key thing to note with apply is basically it's the format is essentially like it's a function and then args basically, and here you can have like keywords. So this is the general format of apply. And one thing to note is actually like this apply itself is deprecated since version 2.3, and an equivalent function is just use function, same function with star args basically, and star keywords, and like directly this will actually work better basically in this context. So now let's look at some other function. This is what is called the map function. So the map calls a given function on every element of a sequence essentially. So once you specify the sequence, essentially like it basically it's kind of iterate through that sequence. So essentially, like in other words, it's basically applying the function to every item of the iterable and return a list of results. So you can have a single function which will take a single argument, but you can apply that to a sequence and then get a result essentially. So you can think of this as like a vectored function. If additional iterable arguments are passed, the function must take that many arguments and is applied to the items from all iterables in parallel. If one iterable is shorter than the another, it is assumed to be extended with none items. So we saw the none actually previously, and so the remaining will be treated as none for that particular iterable. And if function is none, the identity function is assumed. So if there are multiple arguments, map again returns a list containing consisting of tuples containing the corresponding items from all the iterables. It's just a transpose at that point. The iterable arguments may be a sequence or any iterable arguments, and the result is always a list. So that is another thing that you may want to look at. So here is an example. It's called double x return times 2. So if you want to apply to this sequence like 1, 2, and 3, all we got to do is the map and then the function name followed by the iterable, which is here in this case it's the sequence A, and then you get like 2, 4, 6 as a list. So this is a list. This is the iterable. That's the function. So the maps general thing is basically it's map. You have a function and then set of iterables. Okay. So what this means is like if we have another set called B equal to say 1, 2, 3, 4, and then if you say map double A comma B, so now the answer is going to be like you have 2, 2, 4, 4, 6, 6, then 0 or none, 8. So that's the list that you're going to get back. And then we can also like add the lambda inside this map function. So here directly we write lambda x times 2 and then a and then the same result. So here we don't have to specify that this x equal to x plus x times 2. This is a another function called double. So omit this double and then directly like map this and get the same answer. So some more on map. So here this is something that we saw earlier. We can also like add these two essentially, like so here we specify two variables basically x and y. X plus y is the thing. So here this sequence is assumed to be x and this sequence is assumed to be y. So you get like every pair added and that will be the result. So 1 plus 4 is 5, 2 plus 5 is 7, and then 3 plus 6 is 9. Again here if you omit one of them, say like it's 1 comma 2 and then this is 4, 5, 6, then our answer will be like 5, 7 and then 6, 6, because third argument is assumed as null. So it won't error out saying that they are two different um, size arguments, it will just generate this result. So now the next one is filter. So these are all like built-in functions. There are many built-in functions um, in Python. We will go through like some of them. Let's see, like I mean, we may be able to go through like some more later on. So the next one is filter. The filter command essentially is it works on lists. Unlike map, it returns only the selected list of items. So we saw the filter commands in Tickle to specify like I mean some way to restrict the data. So similarly, like we can also use filter in Python, and then the filter command essentially like I mean it's basically like, so you can specify filter as filter function and then the iterable. So this is the typical specification, or this is the format for the filter command. Basically what it says is to construct a list from those elements of the iterable for which the function returns a true. Iterable must be either a sequence, a container which supports an iteration, or just an iterator. And the iterable is a string or a tuple. The result also has the same type. Otherwise, it always returns a list. The function, if the function is none, basically like here there is nothing, none, then the identity function is assumed and basically it just copied back. So the same thing is just return. So all elements actually like I mean all elements that are false they are just removed, and then you get only all the true elements. So that's something that you may want to know. So the other thing about filter is also basically like when you specify like function and iterable, it's equivalent to item for item in iterable if function item. So this is the same as item for item in iterable if function item. So you can think of filter as a shortcut for this command, basically item for item in iterable if function item. So the function item returns either true or false. So if this is true, then that becomes the item from for, and you iterate inside this iterable all the items. Look at all the items. So that is kind of you can think of this basically as how it is actually written. And you can also add additional conditions basically, that is you can say like if function is not none and the item for item in the iterable if item basically like, so it also tests for whether item is true or not if function is none. Okay, so that is the second condition that I talked about. So here we have an example. It's basically filter lambda x, you know this one basically if the the remainder essentially like from that division is equal to 0, and then we give this range that is -4 to 4. That's your iterable. The range is iterable, and then the function is yeah. So now we will see like how this thing is this thing works essentially like so. It iterates from minus this 4 to 4 and each one, and then basically it divides by 2 and then compares the remainder. So whether that is equal to 0. So for 4 minus 4 the remainder is 0, so this becomes true and that's filtered out. Next one is minus 3, and the minus 3 actually like now the remainder is not 0, it's actually minus 1, so that's omitted. And then when we go to minus 2 again it is 0, so it prints 2, and then same like 0 and then 2, so it prints out all the even numbers within this range. And if you look at this one, there's one thing is basically it's not, the last one is not listed here, basically it only up to 2, it's not, the 4 is not there. That's because if you recall, the range function does not include the last value given in the range, so it is like n minus 1. So you may want to pay some attention to this essentially like when you are actually writing the program, because if you want to include that 4 then you need to extend the range past the 4. Okay. So now we go to another function called reduce. Reduce is just like map, but it reduces a list to a single value, and then this is using some operation. So again it's a function and iterable, but here the function is essentially like just go ahead and add the, or basically like there is a it essentially like gives the last so so it reduces this list into like just a single value. So each operation acts on the result of the last operation and then the next item in the list. So here we say like lambda x y x plus y. So basically it just first one is like it's again 0, so it's basically it gives to 0, and then it adds plus 1 plus 2 plus 3 plus 4, and then the final result is 10. So now let's see some the list comprehensions. These are really not functions, but they can replace functions, basically maps, filters, etc. So essentially we can specify the list as essentially like x power 2 for x in range 9. So it gives you all the square numbers from 0 to 8, as you know, like the 9 is excluded from the range, so that's what you will get. And then we can also like to get idea of actually like a square number, and then which is also divisible by 2 or even square numbers. That for that we just specify this basically like this is like all the way to up to 9. So it prints 0, 4, 16, 36 and 64. It omits 1, 9, 25 and 49. So essentially like so it's like functions that you are putting it inside a list, but it is expanded, and basically it's expanded as a function, and then with the real operation that goes on. Now the other one is x plus y for x in 1 2 3 and for y in 100 200 300. The result is basically it adds up x plus y for each of the x, so it's 101 201 301, then 102 202 and 302, and then finally 103 203 and 303. So this is the result. So we talked about the iterables. So there is a concept of generators and iterators. Sometimes it may be useful to return a single value at a time instead of the entire sequence. So for that we use the generator. Essentially, generator is the function which is returned to return values one at a time. The generator can compute the next value and save its state and then pick up again where it left off when called again. So syntactically the generator looks just like a function, but it yields a value instead of returning one. So and a return statement will actually terminate that sequence altogether. So until we see a return statement, basically it keeps that single value around. So here is a generator example. So we define squares essentially, and then for I in range x, yield, that is the new one, this is the generator, and then I power 2. And then we basically use this as for I in squares x, squares 4, print I. So now it is going to print just one value at a time, essentially that is 0 1 4 9, and it keeps the last value at this point. And then we can get the next element in the sequence from the next function. So z squares 4, and the first time z next, when we use it, it becomes 0, which is the first one, and then the z next will become 1, and then so and so. So now the persistence of mutable default arguments. So the default arguments which are mutable persist between the function calls essentially. So these are like static variables. So if they are like mutable default arguments, they continue between the functions. And this may not be the behavior that we want. So if we don't want this behavior, we need to copy the default at the start of the function body to another variable, or move the default value expression into a body function and the body of the function. So this is basically like something that you may want to pay attention. Again, this is another quirk of Python. Because of this, we want to do this. Okay. So now that finishes this this lecture. So in this lecture we actually went to a couple of things. One is mainly the lambda function. Then we also looked at some of the default functions that are available inside Python. The few ones are like the apply, which is kind of deprecated right now. You can use just the function call just like what is specified here as directly, and then the map function. Then we also looked at the filter, and then reduce. We also kind of learned how to write functions in form of lists basically. So if they are not lists, then we actually write functions, and it is comprehended as a function, and it is applied as a function. So we can actually like write these kind of commands into a list syntax, and then call it as a function. And then finally we actually learned about the generator as a concept. We still need to look at the iterators, which we will do at a later stage. But so and then we saw this example of how to use the generator. And then finally, one of the rules of Python is essentially like any kind of default arguments, they persist between the function calls if they are mutable. So if you don't want this behavior, then we need to copy the default at the start of the function body to another variable, or we have to move the default value expression into a body of the function. So inside or outside, change to another variable. So that's pretty much the lesson for today, basically the lecture, and again we will pick it up in the next class. Okay. Thank you.